All right, so we're looking at our first day of 3 days on the sine law. We're not to be confused with SOHCAHTOA when you learn about the sine ratio for right triangles. This is dealing with acute triangles right now. So this is the trigonometry of acute triangles. First question is a bit of a review. Basically, it's asking you to solve for cos x and just seeing if you can isolate that. What I did here is, first of all, I took the negative 2 cos x, brought it over, and then took the 129 and brought it over. So you'll notice that I ended up with, let me just erase that quickly, you'll notice that I ended up with the negative 129 here, and of course a positive 2 cos x on the left side. Then I divided both sides by 2 because I wanted to isolate the cos x. So I divided both sides by 2, and you end up with c squared minus 100 over 2. But keep in mind the c squared is being divided by 2, and the negative 100 is also being divided by 2. So you can simplify it like that, c squared over 2 minus 50, because as you know, negative 100 divided by 2 is negative 50. And I don't know why there's a red dot there, but you can ignore that. All right, so moving right along, the sine law is basically a, or the side length, the side length, and the sine of its corresponding angle. So a and the corresponding angle, sine of the corresponding angle a, and then is equal to b and the sine of its corresponding angle b, and of course side length c and the corresponding sine of its angle c. Those are all in the same ratio. So let's take a look at an example here. Find the length of the indicated side of each triangle to the nearest tenth of a unit. So in this triangle here, we are given angle P, and we're also given the corresponding side length, which is 8. And then we're given angle R, but we're not given its corresponding side length. But we can easily solve that because we know, as long as we have this is the key that unlocks everything. Think about it like this though. If you have A over sine A and you have B over sine B, as long as you have 3, as long as you have, for example, 1, 2, and 3, you can solve for B, right? Any 3 of those, as long as there's only one unknown, right, and you know the other 3, you can cross multiply and solve. So that's what I did here. So I just wrote this as R, side length R, which we don't know, over its corresponding, the sine of its corresponding angle, is equal to P over the sine of its corresponding angle P. And then I just filled in what I know here. I know that sine R is really sine 57. I know that P is actually, as you see here, P is actually 8 centimeters, and sine of angle P is sine of 68. I'm just going to clear that up as well. And then once I know that, I cross multiplied, so I got 8 sine 57 equal R times sine 68, and then divide both sides by sine 68 to isolate R, and if you round to the nearest tenth of a unit, you get approximately 7.2 centimeters. Okay, and so basically you're going to try this one on your own. Okay, round to the nearest tenth of a unit, and then for this one it says draw a diagram for an acute triangle PQR with angle P being 64, side length P being 5.7, and side length R equaling 4.1 centimeters. So remember, an acute triangle means all angles are less than 90 degrees. Okay, so I've drawn the acute triangle here. I have labeled angle P 64 degrees and its corresponding side length 5.7, and then you have R being 4.1, but we don't know what that is right there. So it's asking you to find angle R. All right, so that's what you're going to do in that question on your own, and the next lesson we will do the next day. For now, that's what you have, and of course when you come in we will have some seat work to do, which is number 1 to 7. See you in class.